let's talk about speed. So speed here, it's represented by the symbol v. And since there's no right arrow on top, speed here is a scalar quantity. So there will be no direction involved in this physical quantity, speed. Okay, so speed here signifies how fast an object is moving. If it covers a lot of distance within a short amount of time, we say that the object is moving with a high speed. Okay, if it covers a little distance within a longer amount of time, we say this object here is traveling at a lower speed. Okay, so we go back to our same example. A person standing on the origin, run towards T1, make a U-turn, pass through the origin, then move towards x equals to -7 at time 3. Okay, so let's say the duration from T0 to T3 here is 5 seconds. So if you want to find the average speed from T0 to T3, what we do is we take the total distance traveled from time 0 to time 3 and we divide by the duration from 0 to 3. And we already mentioned that from 0 to 3, we say that the duration is 5 seconds. Okay, so this is writing a symbol is distance from 0 to 3, time from 0 to 3. And since we have already did this calculation in the previous video, I will just take the answer 50 meter. This is the distance traveled that we have determined in the previous video. So if we bring that over, sub in 50 meter for our distance, sub in 5 seconds for time, we'll get 3 meter per second as our average speed. Okay, so what does this 3 meter per second means? It means if you travel at this speed, you are able to cover this distance at 5 seconds. If you travel at 3 meter per second kind of speed, if you cover 3 meter for every second that has passed, if you cover 3 meter for every second that has passed, then you'll be able to finish the distance traveled within or at 5 seconds. Okay, that's the idea of average speed. Okay. Now, if we move on to instantaneous speed. Okay, instantaneous speed here referring to the speed at a specific moment, at a specific instant. Instant means a specific moment. Okay, so if you try to find instantaneous speed at a specific moment, which we call v, what we do here is we take the equation for average speed. Average speed we cover for a certain duration, right? But since now we want it for a specific moment, it's a very small time duration, right? You can think of it, this specific moment here is the specific 0.000000001 second. You can think of it moment like that. So what you do is you limit the time duration towards 0. This limit delta t towards 0 means by you shorten the duration to a very small value that is approaching 0. Okay, in that case, if you write in mathematical form, you introduce this limit, the duration towards approaching 0. Okay, so if you write like that, what does it mean? It means that if you focus on this specific moment time t, it will be a very short time duration. So within this very short time duration, your person, this is the person's head, this is the person's head, and I put a dot here to represent the center of the head. This person here will travel by a little distance, will travel by a small distance within this small duration over here, and we call this the distance travel. So if we sub this distance travel into here, and we sub in the infinitesimally small with small time duration over here, we will end up getting the instantaneous speed that we want at this moment t. Okay, let's say t here is the 4th second. Okay, t equals to 4 means by t is the 4th second. So let's say 1, 2, 3, 4. 4. When you reach time equals to 4 is over here. So let's say you want the speed at this specific moment. So theoretically saying, I'm not saying in actual case you need to determine it this way. Theoretically, what does the limit here says is you measure the distance traveled when it's at 3.9999999 seconds from 4.22 to 4.000000001 second. Within that very short time duration, how much distance has traveled? So you submit the total distance traveled, the very short amount of distance traveled with the time duration, the very small time duration, and you calculate the d divided by delta t for that very small time duration, then you get your instantaneous speed. Okay, that's the idea behind instantaneous speed. But the thing is, if you want to determine instantaneous speed, you have to know exactly how the object moves from here towards here towards here. You have to know exactly what happened at this moment, whether it's sprinting at this moment t, or it's jogging at this moment t, or it's slowing down at this moment t. You need to know how exactly it moved at this specific moment in order to obtain the instantaneous speed. So actually for this whole journey here, for any particular moment, it's actually we are unable to determine the instantaneous speed at any moment over here except for one single moment, which is the moment that this person makes a U-turn. Why do we know the instantaneous speed at this moment? Because for any object that makes a U-turn, if you follow my pen, if an object makes a U-turn, you notice that it will have to stop at the position where it makes a U-turn. If you observe, no matter how fast I move towards one direction, to make a U-turn, I have to somehow stop for a split second before I'm able to change direction. That's just how things move. In order to make a U-turn, you have to make a little stop before you are able to change your direction. And since we define t1 to be the moment that the U-turn is being made, we know that the instantaneous speed at this instant is 0. Okay, you must stop for a little while before changing direction. Okay, so for the whole journey, we are unable to determine the instantaneous speed at any single moment except for the moment that it makes a U-turn. If you want to say, there's probably one more moment that you might know, t0. At t0, the person is still standing, right? It haven't started moving yet. So at that moment, it might be 0. But if he's probably moving, if earlier it has been moving, then it might not be 0. Okay, that one is a bit ambiguous. We have to look at the situation clearly. Okay, so that's the idea of instantaneous speed.